This is Test 2 Section 8. The key with practicing SAT problems isn't just to do 100 different SAT problems, but doing them and then going back to make sure that you know how to do them. So that's why I'm doing these videos. You can fast forward if you got the easy ones right, or you can watch the whole thing and learn different. If there's a faster way, then that I do it, maybe you can learn how to do it faster, and if you can do them faster, you can spend more time on the difficult problems. So let's just start. Number one. See if I can get a pen that works here. Hold on a sec. Okay, if a film takes 90 minutes to show, what fraction of the film is completed 15 minutes after it begins? This is a simple fraction problem. So 15 out of 90 would be what? And I'm going to go quickly on the easy ones. 1/6, because this particular test I thought had some difficult problems on it. So it's 1/6 if you reduce the fraction, and you get 1/6. All right, triangle HJK. Above angle JHK is a right angle. Which of the following lengths is the greatest? Well, this is drawn to scale, so if I look to see which is greatest, I would just say JK is the greatest. If you want to know how this really works, the side opposite the right angle is always the largest, so that would be JK as well, or you could just eyeball it. Next, the table above shows a linear function. What is the value of p? Well, if it's a little linear function, these are going to increase the same amount. This is going to be a +1, this is going to be a +1, and the same for the second one. So from 7 to 13, it's +6. From 6 to 19, it's +6. And even from 31 to 37, it's a +6. So we're just going to take 19 and we're going to add 6. And you get 25. And that's that. That's just looking for a pattern, working it through. All right, down here. Charlie has built houses for 5 years less than twice as long as May has. If May has built houses for n years, which of the following expressions represents the number of years Charlie has built houses? Okay, simple algebra 1. Charlie has built houses 5 years less, so you're going to put that at the end. Like if I would say, what is 3 less than 8? You wouldn't say 3 minus 8, would you? If it's 3 less than something, you have to put it at the end, so it would be 8 minus 3. So that's why we put that at the end. So 5 years less than twice as long as May has. I'm just going to use the M, because that makes more sense to me right now. If May has built houses for n years, which of the following expressions? So M would equal n, really. So the only one that matches, even what I've done, is 2n minus 5. Just make sure you get this part less than. Make sure you subtract it off the end. Remember, 3 less than 8 looks like this if we were to write it out, not like this. They have that answer waiting for you. That's the wrong answer. Okay, next one. All right, in the figure, P lies on AD. PC bisects angle BPD. So that means if it bisects, that means that this angle is going to be the same. That's what bisects means. It divides it into 2 equal angles. You could eyeball this. We're trying to find the measure of CPD. CPD. Obviously, it's less than 90 because 90 would be straight up like this. So it's less than 90. It's significantly less than 90, so I'd get rid of these two for sure. And then you could take a guess after that. You could eyeball it to take your guess. Or you could just know how to do it. If it, on a straight line, the angles all have to add up to 180. So we have 180 minus 80 leaves that there are 100 degrees left. So between here and here would be 100 degrees. And you divide that in half because the PC bisects that angle. So half of 100 is going to be 50. And you could almost eyeball that one. I mean, it would be close between 40, 50, and 60. But because it doesn't say not drawn to scale, you have to assume it is drawn to scale, and then you can do whatever kind of measurements and eyeballing that you want to do. Okay, next one. So we are on 6. Let's wait for that guy to load. All right. So far, this test isn't so bad, but it does crank up a little bit. If x represents an odd integer, which of the following represents the next odd integer? So I'm going to pick an odd integer. I'm going to say let x equal 5. Well, what would be the next odd integer? The next odd, well, it's not 6, so it's going to be 7. So I'm going to put 5 in and see which one gives me 7 as an answer. So let's just see. So it's pretty straightforward. If you add 2 to it, you're going to get 7. So that one was actually pretty easy. If you pick a number, you know the next odd's going to be 2 more anyway. So do that. 5 plus 2 equals 7. Onward. This one here is a little bit tricky. This is where the trickiness, I think, begins with these problems. In the figure above, point T is the same distance from O, from the origin, as point P is from O. Which of the following could be the coordinates for point T? So let's pick some numbers for this. So let's just say it looks like maybe 3, -3 for this point right here. If we're going to do this point, you're going to use the same numbers. So, because it's the same distance. So T over here, if this would be 3, and this would be our -3. This would be our -3. The coordinates for point T are going to be -3, -3. Now, if this is A, how did A change? Well, A used to be positive, now it's negative. B used to be negative and it's still negative. So B doesn't change, A changes signs. So here A stays the same. Well, we know it doesn't stay the same. I don't know why they reversed them. That doesn't do anything. Reversing doesn't. So the only one that works here is A changed from a +3 to a -3 and B stayed the same. So you're going to go with that one. This one's really tricky the way I did it because I didn't think about it. I didn't show you my thought process totally. It seems easy, but it's very tricky. You have to know in this quadrant, it's going to be plus plus. This one is minus plus. This one's going to be minus minus, just for future reference, and this was going to be plus minus. But really, what you want to do is pick a point and then project it over here, and only the A coordinate changes. All right, the next one's rather long, I think. A box contains wood beads, red glass beads, and blue glass beads. Anytime there's this many words, I'm very tempted to skip it and come back to it because it's going to take a little bit of time. So the number of glass beads, so we're just going to call that glass beads, is 4 times the number of wood beads. I'm just going to go and just write some equations down. If one bead is to be chosen at random from the box, the probability that the red glass bead will be chosen is 3 times. So the red is 3 times the blue. Let's see, that a blue glass bead will be chosen if there are 12 red. So it's telling us how many red there are. There's 12 red beads. What is the total number of beads in the box? Well, if the red beads are 12, and we know that 3 times what gives us 12, we know the number of blue beads are going to be 4. So the total number of red and blue beads are going to be 16. So these are our glass ones right here. The red and blue are going to be our glass beads. So we can figure out the number of wood beads. You could just put this in here. 16 equals 4 times the wood beads. The wood beads are going to equal 4. So this is your glass beads, and our wood beads would be 4. So it's going to be a total of 20. So that's going to be A. It's a little tricky because you're dealing with probability versus actual numbers. So when you hit one of those, just set up your little equations and do some substitution. All right, next one. 9 through 11. That will load in a minute. There we go. I don't think I can make this any bigger at this point, so let's go with it. Which of the following graphs is a reflection across the x-axis? Well, all you're going to do is flip it over the x-axis. So this point, instead of being down here, is going to be up here. This point, instead of being up here, is going to be down there. And so we're just going to flip it over the x-axis like that. So it's just going to be this one right here. It's not moving left or right at all, this one. It's just flipping right over the x-axis. So you're taking it and just flipping at this point down from here to here, or actually from here to here. This point, you're flipping it over the x-axis down there. So kind of common sense. I hope most of you got that one right. But you might not know what it means to reflect over the x-axis. So this is the x-axis. That's where it's going to flip over. So whatever axis it says, that's how you're going to flip it. All right, 10 is a difficult one. So we're only on 10 and they're already getting difficult. I thought this test was kind of scary. All right, there are 3 different ways to do this problem, and I'm going to show you all 3. As torturesome it's going to be, but it depends on what your skill level is. The first one, when you look at this, you can think, I'm going to FOIL these out. So this would be x plus y plus y times x plus y equals 100. And then x minus y times x minus y equals 16. I think this is the most advanced way. So let's do this first. So you're going to FOIL it out. So you're going to, I hope I have enough room for all these methods. I'm going to use x squared plus 2xy plus y squared. If you do first, outer, inner, last, and add the middle 2 equals 100, or you do it in your head. X squared minus 2xy plus y squared equals 16. And you're like, where is that going to go? If I add these equations together, I get 2x squared plus 2y squared equals 116. And that doesn't help us. We're trying to find the value of xy. So we're trying to find the value. So here we see an xy. If we can just get the xy's alone, we can figure out what the solution is. The only way to do that is if we multiply the bottom equation, this is very tricky, by -1, we can add these 2 equations together and we're going to eliminate this column and this column. So let's just do that. If I multiply by negative, they're going to add out. This is going to become a positive. This is going to become a negative. This is going to be a negative, and this is going to be a negative. So I'm going to add this column right here, and I'm going to get 4xy equals 84. I think that's what it is. Let me just look in my book, make sure I have the numbers right. 84, yeah. Divide by 4, and so we're going to get xy equals 21. That was very tricky. Okay, that was method 1. So here's our answer at C. All right, method 2 is you can say x plus y squared equals 100, and x minus y squared equals 16. Well, that means that x plus y has to equal 10, because 10 squared is going to give us 100, and x minus y has to be equal to 4, because 4 squared is equal to 16. So then I do it this way. I get 2x equals 14, x equals 7. So that means y, if I have x equals 7, x equals 7, then y has to equal 3 in order to get this 10. So y equals 3, x times y is going to equal 21. Okay. All right, third method. So this is 1, 2. Now obviously this problem won't take this long because you're going to pick one method and not do all 3 of them, but it depends where your skill level is in algebra, how you do this problem. Okay, here's the low level skill person. You don't know your algebra very well, which is okay, but you have to learn different methods. Now I'm going to take these answers and I'm going to divide them into their factors. So I'm just going to start first of all with the ones without, no, I'm not going to use the 6 times 1 or the 10 times 1. I'm just going to write down factors. So I could have 2 times 5, I could have 3 times 7, and 5 times 5, and that one is just 1 and 29. It's prime. So I'm just going to start putting them in for x and y. So x plus y, if I do, I'll do method 3 in red down here. So if I let x equal, I'm going to let x be the bigger one because here we're going to be subtracting. So I'm going to let x equal 3 and y equals 2. And if I put them in, I'm going to get 2 plus 3 is 6. And 3 minus 2 is 1. And I'm not going to get, and I'm going to square it. Yeah, square it. I'm going to get 37. So that doesn't work. Let's do the next one. Let's let x equal 5. And obviously we would have started at C because that's what we're supposed to do, but I didn't want to get the right answer right away. So y equals 2. And if I put those in there, I'm going to get 7 squared times, oops, I think I messed up on that first one. 7 squared does not equal 100. Yeah, I think I totally didn't do this one right. This red's just killing me. So if I put the 3 in and the 2 in right up here, 3 and 2, I get 5 squared does not equal 100. So we can do the same thing. 5 plus 2 is 7 does not equal 100. Let's go to the last one. So we're going to do 7 and 3. So x equals 7, y equals 3. So if I put them right in here, 7 plus 3 is 10 squared is 100. And now we have to try the second one. 7 minus 3 squared is going to be, so 7 plus 3 squared is 100. And 7 minus 3 squared does give us 16. So the red method is if you're just going to pick numbers and just work with the factors. All right, none of those are easy. The more you know algebra, the easier the SAT can be. So, all right, which of the following represents all the values of x that satisfy the inequality? Well, let's just solve the inequality. So here's the inequality. I'm going to add 5 to both sides, so I'm going to get 4 is less than or equal to x. And if we, 4x, divide both sides by 4, so we get 1 is less than or equal to x. And I'm just going to flip it around. X is greater than or equal to 1. And this would be this graph right there. I would hope that one's kind of easy for you. If it's and equal to, you're going to color in your circle. This one would have been x is greater than 1, but that's not what it is because it's not colored in. So that's only 1. So it's a real simple inequality to solve, and that's it. All right, moving on. So 9 to 11. Okay, this one's a little blurry. I apologize for that. You have it in your book though, so. All right, so here we go. These are really tricky, these final ones. In the figure above, whose rectangles are shown, they have a perimeter of 12 or inscribed in the circle. How many other rectangles with perimeter 12 can be inscribed in the circle? Okay, very tricky. The temptation to do right now is to make some rectangles according to the points that they give you on the circle. So they're that one, and then we can do this one. And so your tempting answer would be to say 2. However, in a circle, you can pick any points. So I could have picked a point right here. Let's just go with a different color here. So I could have picked a point right here, and I could have made this A, and this one B, and this one C, and this one D. And I could have done another rectangle with the same lengths. So the bottom line is we could do an infinite number of equal space points around the circle and draw rectangles. We could have put one in between here and here and done another rectangle. So there's an infinite number of rectangles that you can do. So you would say more than 4. And that one is really, I mean, it's easy once you see it that you can do an infinite amount of rectangles. You can keep rotating these rectangles degrees. You can do it 1 degree, 2 degree, 3 degree until you have rectangles going the whole way around. So it's going to be infinite. So more than 4 is their version of infinite. Okay. Okay, just look out. You have to watch out for those because they're so tricky. It's not a difficult problem, but they're trying to trick you there. Okay, I'm going to draw this one over. I thought this one was rather hard too. So we get 2n plus 2n plus 1 equals k. we are supposed to find 2n plus 2. It says if n is a positive integer, then we have this. What is 2n to the 2n plus 2 in terms of k? Very tricky. So n is any positive integer, so I'm going to say let n equal 2, and I'm going to figure out what k is going to be. So here we go. It's pretty simple once you start picking numbers. This is the second method that we talked about in class. So we're going to have 2 squared plus 2 to the third is going to give us k. So we're going to get 4 plus 8 equals k, and we're going to get 12 equals k. All right, now we need to figure out what 2n plus 2 equals if k is equal to 12. They're giving us the answers here. So we're going to take and we're going to put, we have to figure this out first. So we have to do 2, we decided that n equals 2. 2 to the 2 plus 2, which would be 2 to the 4th power, is 16. So we're going to put this back up in here into the k's and see which one gives us 16. So let's start with C. So I think it says 2 times k. So that's going to give us 2 times, that's going to be 24. That's too big. So let's work our way up. So 4 times 12 divided by 3. This would go in 4 times. 4 times 4 is 16, so this is our answer. These take a little bit of practice. That's why we're doing so many SAT practices, because you're going to learn which method works the best. I'm sure there's a way to do this algebraically, but I would never want to do this. So when it says n is a positive integer, that's your key to pick an integer. So if it equals k, we can find out what k is, and then they want to know what 2 to the n plus 2 is in terms of k. Well, these are going to be the answers, so you have to work from the answers. Kind of tricky. All right, next one's tricky too. The triangle above is isosceles. AB is greater than AC. So I'm just going to put, since AB is greater than AC, I'm going to put 2 slashes on here to show that it's bigger than this side. A thing that comes up all the time on SAT problems, or at least once every so many tests, is knowing that the angle opposite the largest side is the largest. So we know that this angle right here is going to be bigger than this angle, no matter what. So whatever, this is a z. So z is always going to be greater than y, no matter which 2 sides are equal. So if you look down here, it's a little tricky. You can draw these figures out, because there's the case where AB, both sides are equal to AB, and there's also the case where both sides are equal to AC. It's a little tricky. But if you get this point, let's just stick with this. Z has to be greater than y. Is there any cases that contradict that? Well, right here it says y is equal to z. So you have a contradiction. Z always has to be greater than y. So this one has to be false. So I'm just working with contradictions there. Okay, last page. Okay, more tricks to deal with. The graph above shows the distribution of Tom's $240 trip expenses. The amount Tom paid for the hotel room was only part of the total hotel room cost, because he shared the cost equally with 3 other people. What was the total cost of the hotel room? Now, this problem is a very easy problem. It's at the end because it's very tricky. There's a trick built in, so a lot of kids miss this problem, so that they stack them by, they'd use the experimental section, and when kids miss a problem a lot, they put it at the end. But this one is not hard. It's just tricky. Okay, so here we go. He spent $240 on the trip, and 20% of that was his hotel room. So I'm going to take it times 0.2. That means he spent $48 on the hotel room, and it's divided equally among 3 people. So, with 3 people. That's the key right there. It's divided equally with 3 other people. So, our temptation is to multiply this by 3. If you multiply it by 3, let's see what we get. 4, 12, 13, 14, 144. our temptation is to put the answer C. You can see it's waiting for you. Here's the trick. He shared the cost equally with 3 other people. So how many people were in the room? There are 4 people in the room. So we're going to take 48 times 4, and when we do that, we're going to get 192. So it is actually D. Here's the trick. Make sure when you read these word problems, you look for the trick in the word problem. It's shared equally with 3 other people, 4 people in the room. Okay, last problem. This one's a difficult one, which you would expect for number 16. So on a square game board that is divided into n rows of n squares each, k of the squares lie along the boundary of the game board. Which of the following is a possible value for k? All right. I don't know if there's an easy way to show this, but I'm going to start out with a 4 by 4. So we're going to have 4 this way. We're going to have 4 down this way. And we're going to have 4 this way. This one takes a little bit of time to explain. And 4 this way. 1, 2, 3, 4. Okay, if it's a 4 by 4, how many are going to be on the edges? Well, I just do 4 plus 4 is 8 plus another 4. So it's going to be 12. So we're going to start out with that, 12 on the outside. Let's move on. So if if the number of rows equals 4, then there are k equals 12. So I'm going to do a little chart down here to help keep track of things. All right, let's do a 5 by 5. So if we have a 5 by 5, I'll just draw one more and then we'll make deductions here. Whoops, that was a really bad straight line. All right, so let's do 5 by 5. That looks more like a rectangle. Mine does. 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. Okay, and the same down here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so if it's a 5 by 5, we have 5. So we're just kind of doing 5 on the bottom, 5 on the top, and then you take away 2 from the side. So it's going to be 5 minus 2 is 3 and 3. So we're going to get 10 plus 3 is 16. So if n equals 5, k is equal to 16. Now I'm trying to develop a pattern here. Let's do one more. We can do a couple more. If we have a 6 by 6, remember the little thing, you're going to have 6 on the top, 6 on the bottom, then you have to subtract 2 for the sides because you can't count these twice. So it's going to be plus 4 plus 4. If we add those together, 12 plus 8 is 20. So we're going to get k equals 20. Let's do one more. N equals 7. We actually don't need to do another one. If you look, well, let's do 7 just for fun. So 7 plus 5 plus 5 is going to be 14 plus 10 is 24. Now you can see what's happening. We're adding 4 each time. Adding 4. These numbers are all divisible by 4. That's our pattern. So I'm going to go up to our answer choices and I'm going to say which numbers are divisible by 4. Not 10, not 25, not 34, not 42. The only one divisible by 4 is 52. Or you can just keep adding 4 until you hit 52. So you get 28, etc., 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 until you hit 52. So this is an example of one where you start the problem and try to find a pattern. All right, I hope you watched this, and this is it for Test 2, Section 8.